Hello, my name is Marina Flores, and this is my Discrete Math Test None video. The problem that I chose for this test was problem 16, where I was to use the repertoire method to solve the general four-parameter recurrence. I was given the equation for the recurrence g of 2n plus j equals 3g of n plus gamma times n plus beta sub j. And I was given the restrictions j must be equal to 0 or 1, nothing else, and n must be greater than or equal to 1. And then we were graciously given g of 1 equals alpha, and a lovely hint that g of n must equal n. So our goal for the problem is to just explore the problem and find alpha, beta, and gamma. We're not going to find the closed form because that's too much work, or so I say. Anyways, so when we're going to explore it, we're just going to remember what equation we have. We have g of 2n plus j equals 3g of n plus n times gamma plus beta sub j. First, let's just find g of 2. So to find g of an n, we're just going to set our left side of the equation equal to what we were trying to find, g of 2. So when we're doing this, we notice that we need our n to equal 1 and our j to equal 0. So that 2 times n, or in our case 1, plus 0 is going to equal 0. I mean, not 0, it's going to equal 2. So then we can plug that into the right side of the equation to get 3g of 1 plus 1 gamma plus beta sub 0. And then we know that g of 1 equals alpha, so we just plug that buddy in to get 3 alpha plus gamma plus beta sub 0. And then we do the same for g of 3 to get 3 alpha plus gamma plus beta sub 1. And then we are finding g of 4. We do the same thing to just understand what our n and our j is. And then when we're doing g of 3 times g of n, we're doing 3 times g of 2. So we're going to use the equation that we found for g of 2, plug that in, and we're going to distribute the 3 to all of these lovely, lovely terms here. And then add like terms or combine like terms to get g of 4 equals 9 alpha plus 5 gamma plus 4 beta sub 0. And we're just going to do that for g of n all the way through 9, g of 9, just to find a lovely, lovely pattern. And I don't want to bore you with all this math, tedious, tedious math. That was actually kind of fun to do, I will admit. So we notice this lovely pattern when we look at the values of n and j from g of 2 through g of 9. For n's, our n's repeat. They do 1 and 1 and then 2 and 2. It's always in like patterns of 2. And then our j's are alternating between 1 and 0. I don't know if that's anything to do with anything, but it's very interesting. So these are all the equations that we found, which are going to be important later on. So let's explore the problem a little further and remember that g of n needs to be equal to n. So n must be equal to 3g of n plus n gamma plus beta sub j. So let's look at g of 2. So g of 2 equals 3 alpha plus gamma plus beta sub 0. So let's make just regular old 2 equal that equation. And I think it is reasonable to assume that beta sub 0 equals 0. So let's just let beta sub 0 equal 0. So 2 is equal to 3 alpha plus gamma plus 0. So just alpha would be alpha plus gamma. And then let's look at number 9, or g of 9. And let's just reasonably assume that b sub 1 equals 1. This is just an assumption. We can change this if necessary or if it doesn't make sense. But I think it makes perfect sense that, it would just equal 1, So we just plug in our beta sub 0 equals 0 and our beta sub 1 equals 1 into our equation for g of 9. So we get 9 equals 27 alpha plus 19 gamma plus 1. So that means this equation must equal 9 just to satisfy our little hypothesis, or what we're given, that g of n equals n. So let's try to find alpha, beta, and gamma just to satisfy what the equation that we had earlier, the whole 2 equals 3 alpha thingy and 9 equals whatever that was. So let's just rewrite the coefficients of alpha, gamma, beta sub 1, and beta sub 0. One could say this is like the start of a closed form, but at this point I'm just using inspiration from our textbook. Not textbook. Our notes. Our notes. So let's just say that g of n equals a of n times alpha plus b of n gamma plus c of n beta sub 0 and d of n beta sub 1. And we already assumed what beta sub 1 and beta sub 0 are, so we can just plug those in. So n is going to be equal to a of n alpha plus b of n gamma plus d of n times 1. So we need two terms to cancel out, because if we're just going to have this, and if this is our n, so it's going to be n plus n times 1, so we can just have n times 1, so n times 1 equals n, but what do we do about these? These need to cancel out. Fortunately, we know that g of n equals alpha, and since g of n must equal n, then alpha must equal 1. So if alpha equals 1 and we need to try to cancel something out, then gamma must be -1. Mind blown. So we need our n to equal this, which must equal this, what we just made up. So for that to happen, we must think that alpha is 1, gamma is -1, and beta is 0. And the math checks out, guys. The math checks out. It all adds up. Thank you.